In this video, we are going to discuss about apparent power and also power factor. So, in the previous video, we have discussed what is average power. Right? What is average power? Average power is equal to 1 by 2 into Vm Im cos and del V minus del I. Okay, so this I can write it as Vm Im divided by root 2 into root 2 cos del V minus del I. Okay, this I can also write it as Vrms into Irms cos del V minus del I. Okay, so this Vrms into Irms, this is nothing. I can write it as S. Okay, S into cos del V minus del I, where S is nothing but your apparent power. Apparent power, that is equal to Vrms into Irms. Okay, so I can define this S. It is a product of two term cell. It is Vrms and Irms. Okay, so I can write this average power. Okay, average power P is equal to S into cos del V minus del I. Okay, so this power factor. Okay, power factor, that is PF, that is equal to cos of del V minus del I. Okay, so I can write now P is equal to S into PF. Okay, so what is PF now? PF is equal to P divided by S. So this is also your power, this is also your power. So this is a dimensionless quantity. Okay, this is also measured in watts, and this is also measured in volt ampere. Okay, so the power factor is defined as a ratio of the average power to the apparent power. Okay, so whenever PF is equal to 1, that is when this PF equal to 1 will happen, that is during del V is equal to del I. So del V is equal to del I means it is a purely resistive type, right? If purely resistive means del V is equal to del I. So I will get cos of 0. Okay, the power factor is equal to cos of 0, that is equal to 1. Okay, so during that time, what will happen? Apparent power is equal to average power. Okay, so if it is not the case, if it is not the case, if it is not the case means what will happen? So if it is not the case, means it will be either PF is either leading or lagging. Okay, so this power factor is usually measured in terms of cos, and um, uh, it will tell about cos of that is PF is equal to cos of this one, right? Del V minus del I. So this is nothing but so I can define this one as power factor is a cosine of what is this one? This is a phase difference between voltage and current, right? There's a phase difference between voltage and current. It is also the cosine of angle of the load impedance. Okay. So here it is telling about there is nothing but angle of Z, Z. Okay. So angle of Z. So what is Z? Z is equal to V by I. Correct. So here I can term this one as either VRMS of del V, and this is nothing but IRMS of del I. That is why it will come as VRMS divided by IRMS into del V minus del I. Okay. So this I can also write it as Z is equal to Vm by root 2 divided by Im by root 2 into del V minus del I. So this is nothing but Vm by Im into del V minus del I. Okay. So if you see Vm by Im, suppose the Z values positive value. Okay, if Z value is positive means I can write Vm is equal to Z times Im, right? So here if Z value is positive means so consider if Z value is negative. If Z value is negative means definitely Vm is less than that of Vm is less than Im. Okay, which means I is leading, that current is leading the voltage. So that is why it is called as leading. Okay, so whenever the Z is negative, V value is less than I, which means I is leading the voltage. Okay, so this is also called as leading. Okay, the power factor is leading. Okay, that is power factor is leading. Okay, so whereas for the next case, so if Z value is positive, if the Z value is positive means current lags voltage. So therefore it is lag. Power factor is lag. So you have to remember this one, civil. Okay, so what is civil? Which means in capacitor. Okay, so in capacitor, the C. Okay, current. I means current. Current leads the voltage. Current leads the voltage. Current lead the voltage. Okay, so current lead the voltage means it is leading, right? So if it is leading means the load we are using is capacitive load. Okay, and for capacitor, for inductor. Okay, so you have to start from here. For inductor current, right? You have to come like this. Okay, in this direction. Current lags the voltage. So this is nothing but lagging. So this is called as inductive loads. Okay. So let us discuss some problem based on this so a series connected load which draws current. Okay, current I of t is equal to 4 cos 100 pi t plus 10 degree and Vt is equal to, and when the applied voltage. Okay, applied voltage V of t is equal to 120 cos 100 pi t plus minus 20 degree. Find apparent power and power factor, okay, of the load, and also determine the element value that forms the load. Okay, so we know that P of t. What is P of t? P of t is equal to V of t into I of t, right? So this I can write it as 4 cos 100 pi t plus 10 into 120 cos 100 pi t minus 20 degree, right? So this is equal to 480, right? Divide by 2 into cos 100 minus that is 10 minus minus 20, right? Plus cos of 200 pi t, right? Plus 10 minus 20. Okay. So this is equal to 240 cos 30, right? Sorry, this should be del V, right? So this should be del V means if it is minus 20 minus 10, right? So this is minus 30. Okay, anyway, you will get the same answer only. Okay. Plus 240 cos 200 pi t minus 10. Okay. So here the average power, right? So the average power is equal to 240 into cos 30 degree, right? So here the power factor is nothing but cos of minus 30 degree, right? That is equal to 0.866. So if it is since it is minus means what is minus? Minus means it is leading, right? So it is leading. That is current leads the voltage. So definitely they have used capacitor as a load. Okay, capacitor as a load. So what is Z? Z is equal to Vrms divided by Irms into del V minus del I. Okay, what is Vrms and Irms? I can take this is Vrms values 120 divided by root 2 and this is 4 divided by root 2, right? And what is del V? Del V is nothing but minus 20 minus 10. Okay, so that is equal to 30 and the angle is angle is minus 30. Okay, so I can write this Z is equal to 25.98 minus J50, which is usually measured in ohm. So here this is nothing but it is in the form of R minus JXC, right? So for the load they have used resistor and capacitor. So the capacitor value they are given it as XC. What is XC? XC is equal to 15, right? I can write it as 1 divided by omega C is equal to 15. Okay, so what is C? C is equal to 1 divided by omega values. Here the omega value is 100 pi. Okay, so 100 pi into 15. Okay, so the answer is for 212.2 microfarad. Okay, so this is how the circuit is.